Hello, Geometry. How's it going? Thanks for tuning in. Thanks for watching. Hope your day is going well. Hopefully, a lovely day. Um, Taking the time to watch this video. We are doing notes for lesson 7.4. We are nearing the end of talking about angles in a circle. And we're not done with circles, but we're nearing the end of angles in a circle. And today is just a conglomerate of everything that we've already looked at. So there's nothing particularly new today. What have we already looked at? We've seen central angles. Central angles are equal to the arc. Described angles, and they're equal to half of the arc. We've seen interior angles, and there are arcs that are created. We add those together and we divide by 2. And we've seen exterior angles. We subtract the arcs that are created and divide by 2. So we're looking at these big circles, and we're trying to solve for basically everything. Okay, we're trying to solve for everything. We're given very little information at the start. We know that arc AB is 120 degrees. We know that arc CD is 40 degrees. And we know that AC is a diameter. And that's really it. And we are tasked with solving for all of these missing blanks, okay? So I've said this time and time again that there's no reason to go in order of things. There's no like direct path. There's no one and only path. Just solve for the stuff that feels easy. Solve for the stuff that feels easy. Now, I know you probably, some of you will be like, none of it's easy. Well, yes, some of it is, right? Some of it is easier than others. So, let's start with the fact that this is a diameter, right? When I hear that, I'm like, oh, it's being split in half. It's 180. Okay, so this is 180 and this is 180. Well, hold on. I know this arc, so therefore this arc has to be 60 because the two put together make 180, right? And I know that this has to be 140 because 140 and 40 make 180. So just little things like that. It's like you can just check that off the list. I'm not even looking for what we're trying to solve for. I don't care what I'm trying to solve for, to be honest. I just know that I'm solving for a lot. So I'm not going to go in some specific order. I'm just going to solve for what feels easy. So I have all of the arcs, which is nice. What's the easiest angles of all? Central angles. So I see angle 9 is central and angle 6 is central. So those are pretty straightforward. I know that this is 120 because it intersects this arc that's 120. And I know that this is 60 because it intersects this arc, which is 60. So I got those taken care of. The next easiest in my brain is inscribed angles because I just simply take half of the arc. I just take half of the arc. So I know that angle 2 is 20 because this angle opens up and intersects the 40. Half of 40 is 20. And angle 1 opens up and intersects the 60, so half of 60 is 30. Now, angle 8 starts to open up, but it doesn't truly intersect, right? It stops at 9. 7, however, continues on. It intersects the 40. Half of 40 is 20. And 4 starts to open up, and you know what? It does. I was afraid it wasn't going to touch. It does. It intersects this giant arc that's 120. Half of 120 is 60. So angle 4 is 60. Angle 3 opens up and intersects the 140. Right? There's this angle and it intersects the 140. Half of 140 is 70. Again, how am I doing this so quickly? I'm just super focused on the inscribed angles, right? All of the angles that have a vertex on the edge. And here's angle 5, opens up and intersects the 120. Half of 120 is 60. I solved for a lot here. Now, there's a few things that are missing. 14, 11, and all that. This is an inscribed angle. 11 is inscribed. Now, this is a unique inscribed angle. You know how this angle, let's just, for the sake of an example, let's focus on number 2, angle 2. You see how this opens up and intersects the arc, yeah? It intersects and creates an arc, and it's intersecting at 2 places, here and here, right? And then therefore it creates the arc. Well, angle 11 touches at the vertex and touches at B, and H, it never touches the circle, right? Because it goes shooting off. Well, we still call this inscribed because the vertex is on the edge, and the arc is this whole thing, okay? Half of 120 is 60. So it's a unique inscribed angle. It doesn't actually intersect the circle twice. It only intersects it once at B and then obviously at the vertex. But this arm, if you will, doesn't touch anywhere. So the same thing with 14. This arm intersects at D, but F here, it never intersects anywhere. So we're going from D clear to the vertex, that's 140. So half of that is 70. So that's a unique inscribed angle. What about the rest of this? Well, I see triangles in a lot of places here. I see a lot of triangles. Let's use that, right? Don't be afraid to use, past facts. If this is 30 and this is 120, that adds to 150. So therefore, this has to be 30, because 30 and 30 make 60, and 60 plus 120 makes your 180. Beautiful. Can I manipulate triangles any further? Angle 13 is interior, right? And I could try to use the arcs, but I can't help but notice that this is a triangle as well, right? I'm always keeping my eyes peeled for stuff like that, because in the end, isn't that a little bit easier? Let me make that like a perfect circle. Right? Isn't that a little easier? If this is 20 and this is 60, well, that makes 80. So therefore, angle 13 has to be 100. And again, keeping my eyes peeled for easy things, this is a straight line. And these two angles, 13 and 12, make that straight line. What do we have there? A linear pair. So therefore, this is 80. Always keeping my eyes peeled for stuff like that. Why not? Why not? What else do we got? Angle 10 is the last one, it looks like. 10 is the last one. Is there any clever way to get angle 10? Not seeing it. There are some triangles, but I don't know how big this angle is. I could find that angle. But you know what? Let's actually use exterior angles let's actually use one of the exterior angle things. So this angle, let's focus, right? Here's this angle, and it intersects and creates this arc, right? And it creates this arc, the 120. So with exterior angles, we subtract 120 minus 40 divided by 2. So we have a 40-degree angle there. And we've solved all of it. I'm not going to bother filling in the blanks. I filled it in on the picture. You know what I mean? I'm just that. Now, I found this 100 with the triangle, but what if you don't notice the 100? Or I found this 80. with the fact that it's a linear pair. But what if you don't notice the linear pair? Well, you still need to be aware of some of the other things that we know, right? Like these are interior angles, right? So when these angles, you look at the big arc up here, that's 120, and you look at the small arc right below it, that's 40. What do? You add the arcs together and divide by 2 for interior angles. Well, guess what? It gives you 80, right? You're still going to get the same answer. It's about what you observe. I'm a fan of observing the triangles. To me, that feels easier. Feels a little easier. Let's just keep it rolling, right? It's just pure observation. So fill in what you're told. They tell us a crap ton of arcs. So let's go ahead and carefully fill in all of those arcs. Okay, so I got it all labeled, and GC is a diameter. Let's go ahead and label that. They told us GC is a diameter, but so is B to F. I mean, like, by definition, B to F is also a diameter because it's going through the center. So even though they didn't tell us, it's technically still a diameter. You know what I mean? So again, using the 180s, let's go ahead and finish off the rest of our arcs. We know that this is 180 due to the diameter. So 60 and 80 make 140. So therefore, the remaining piece has to be add to 180. And this is 180, and this is 40, and this is 60. Don't forget the teensy 20. Oh, don't forget the teensy 20. So that's 40 and 60 make 120. So therefore, this is 60. Now, you could add all of these together just to confirm that it adds to 360. Just to double check. 40 and 60 make 100. 40 and 60 make 200. So 280 plus 20 is 300 plus 60 is 360. So 360. All right, so we got that. Again, I like to instantly gravitate towards the easy stuff like central angles, right? Central angles. Why not? So angle 1, boom. I know it's 60 degrees because it's intersecting this arc, right? And boom, I know that angle 2 is opening up to several arcs put together. 40 and 60 make 100. 100 plus 20 is 120. So boom, angle 2 is 120. It's a combination of 20. You also know that it's 120 because it has to be a linear pair, right? 60 and 120 make 180. Right? Little double checks like that can really help. And you know what else sometimes helps? Is just, even though it didn't ask, I mean, it doesn't hurt to label that as 160 and 120. I mean, it's true, right? Those are vertical angles, right? That's true. So, I mean, why not just write it in there, right? I mean, it's not really that time consuming. Because then that might help you use triangle stuff. Right? Anyways, I then like to go towards the inscribed angles, right? Because you just take half, 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 half. That's pretty quick and easy to do. So angle 4 opens up here to the 60. Half of that is 30. Boom. Angle 3 opens up to the 40. Half of that is 20. Boom. Else. Angle 10 opens up to a combination of 40, 60, and 20. Which we already discussed adds to 120. So half of 120 is, boom, 60. Angle 5 opens up to the 40. So half of that is 20. Angle 6 opens up to the 80. Half of that is 40. Angle 7 opens up to a combination of the 60 and 20. So that's 80. Half of that is 40. Boom. That appears to be all of the inscribed angles. The rest of our angles are interior, 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 interior. They're all interior. Now, what do we know about interior angles? You know, when you have your interior angles and you have your two lines that are intersecting randomly in the center, arc plus arc divided by 2 equals the angle. Or, as I did above, there might be some triangles that are rather informative, you know? There might be some triangles that are pretty informative. Upon first glance, I'm not seeing it though, you know, like really. Oh, well, this is interesting, right? You may or may not make this observation, right? You have these intersecting lines, and you know that this angle is the same as this one because they're vertical angles, right? They're vertical angles. Well, if these are vertical angles, if you can solve for this angle, well, then you instantly have 14. This is a triangle. We know this is 20, and we know this is 60. That adds to 80, so therefore this is 100. Boom. Now, if you didn't notice that, you of course could do it the classic way, and that would be this arc opens up to the 120, so 120 plus, this is 20 and 60, so that's 80. So 120 plus 80 is 200. Divided by 2 is, boom, 100. Now, what's easier, right? I don't know. I don't know what's going to be easier for you. If you don't say to yourself, these are vertical angles, if that's not coming to you instinctually, this might seem really bizarre to look at this triangle in order to solve for this angle. But if you realize they're vertical angles, I mean, it's pretty instant, right? If you don't notice that, well, then you got to take your time adding the arcs, and you got to be careful about combining the two arcs, right? They both have their difficulties. What else can we do? You know, little things like 13 and 12 are a linear pair. If I can find 12, well then boom, I have 13. Or if I can find 13, then boom, I have 12. Is there some way I can get straight to it? Now, this might seem a little crazy to you, but here's something that I observe. If this is 100, I know that this right here is 80 because it's a linear pair, right? And then all of a sudden, I have a 1, 2, 3, 4-sided shape. It's a quadrilateral. Instead of a triangle, it's a quadrilateral. And I know there's 360 degrees in a quadrilateral. So 360 minus 120 minus 40 minus 80 leaves me with 120. And then boom, if that's 120, this is 60. Now, what if we didn't see that? Well, then of course, you just use interior angles. This angle opens up to the 40, and this angle opens up and eats the combination of 60 and 20, that's 80. So 40 plus 80 divided by 2 is 60. You get the same answer. 80 plus 40 is 120, divided by 2 is 60. About what you see, what you find easier. There's no right way here, folks. There's no right way. 11. 11, is there any tricks up my sleeve for 11? I don't have any tricks up my sleeve. But let's just do it interior angle style. So we've got this side opens up to the 40, and then the other side opens up to this whole thing. I don't even need to bother adding because I know that it adds to 180 because this is a diameter. But if you didn't, you would just add 60, 20, 60, and 40 all together. You get 180. 180 plus 40 is 220. Divided by 2 is 110 degrees. We also have these exterior angles, 9 and 8. Do we have any tricks up our sleeve for that? I do. I do have a trick, right? This is a triangle. 40, 120, that adds to 160. So therefore, this has to be 20 degrees. Got to be 20. I don't think I have a trick up my sleeve for 9. Anything? I don't see anything. So we'll do it classic exterior angle style. As this opens up, it creates one arc from G to F, and then the other big arc is B to G, right? Which is 120. So 120 minus 60 divided by 2, which is 30. See that? Let me say that again. You've got this angle, and it creates one arc and then two arc on the other side. So exterior angles is big arc minus the small arc divided by 2, which gave us 30. All right. You've seen 2 examples. I'm going to go ahead and do the last one. I haven't had any questions this entire video. I've just been boom, 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 boom. Let's have a question. Well, here, just help me get started on this. Help me get started on this, and that'll be the question. Help me get started, and that'll be the question. So, I have got TA is 30. I've got BC is 80. Tell me, or AB is 70. Okay, they told us that. DT is 100, and CD is 80. Oh, we know all the arcs. I was going to ask you a question about the arcs. Okay, tell me, just one random angle. How big is angle 10? How big is angle 10? Tell me how big it is. Just get that one question right. All right, you should have told me it's 40, right? Because it's inscribed and half of 80 is 40. Okay? All right, that's my question. If you feel comfortable with the circles, you can go ahead and leave the video. If you'd like to see another example or you just want to keep practicing with me, by all means, stick around. Let's finish it out. I obviously start with the central angles, so this is 70. We're not actually told to solve for any of these other angles, but I mean, like I said earlier, I might as well just fill it in, right? Well, all right, so that's all of the centrals now. Now there's inscribed. We got a lot of inscribed. So we already did 10. This 11 opens up to the 70. Half of that is 35. This 12 opens up to the 30. Half of that is 15. This 7 opens up to the 80, and half of that is 40. This 8 opens up to the 30 and 70, so that's 100, and half of that is 50. 9 opens up to the 100, and half of that is interior, I'll deal with a second. Interior, I'll deal with it in a second. 13 opens up to the 80, and half of that is. And then here's our lovely, unique interior or inscribed angles, right? It opens up to this big arc. This is 180 degrees because this is the diameter. So what we have here is a perfect 90-degree right angle, right? Because half of 180 is 90, and the same thing is happening here, where it only touches the one time, right? So we're looking at this arc clear from D all the way to the vertex. So that's 100. Half of that is 50. What else do we have here? These guys and these guys. Well, again, triangles are our friends. This is a triangle. 50 and 40 make 90. Oh, so this is actually a perfect right angle, 90. And then these are vertical angles, so boom, 5 is 90. Easy. This is a triangle. 15 and 40 make 55. So what's left is 125 degrees, because 125 plus 55 is 180. And then 2 and 6 are a linear pair because it's a straight line. So if that's 25, well then this has to be 55 because 125 and 55 make 180. I just said that, except I was talking about the triangle. Well, now I'm talking about a linear pair. And then all of a sudden we're done. So it was a lot going on, but like in the end, I mean, man, these are actually, I don't know who's listening and who's watching the video at this point, but in the end, it's actually pretty easy. I'll put it in quotes. It's not like, oh my gosh, easy, but it's like, there's no algebra here. It's just like, okay, figure this out to figure this out to figure this out to figure. It's just like this domino effect. All of a sudden, it's like what looked hard, you fill this in, and then, oh, that's easy now. And then you fill that in, oh, this next thing's easy now, right? It's just this domino effect. So hopefully you're feeling good. Lovely rest of your day. I'll see you in class.